Hey, good morning, afternoon, everyone. My name is Marabi, and I'm here to present to you my most recent project, which is a look into neural style transfer. So, first off, some of the overview and motivations. I wanted to try to create that Snapchat-like filters, and if you're not familiar, Snapchat's augmented reality filters are created through a number of computer vision problems, and I want to see if I can kind of recreate this with a neural network. Some of the things that this application can be used for is it can be used as a tool for designers and artists. So if you create a new stylized image with a style image, it can be used to test out new fashion designs. Overall, it could be used to test out a lot of different things. And it's kind of motivated from like kind of this stylish type of like aesthetic. So we want to try to create new aesthetics with our style image. So here is some of the related work. The first one to kind of introduce this was Leon Gatsy in 2015 with his paper A Neural Algorithm for Artistic Style, and over the years this has been applied to a lot of different things, such as Justin Johnson with perceptual losses for real-time style transfer. That's a really cool paper because it talks about techniques to do style transfer in real time, and arbitrary style transfer in real time with adaptive instance normalization by Zune. I hope I'm pronouncing that right, Zune. That is a really cool technique because it lets us essentially have the speed of Johnson's, because Johnson's technique is very fast, but you can only train it for one style at a time. Zune, however, neural style transfer is able to do any kind of style with a bigger speed up than Leon Gatsy's. And some of the other people I've watched to kind of understand this is Ayush in his artistic neural style transfer from scratch. He has an amazing tutorial out there. Code This, Code That basically broke down Leon Gatsy's paper in a very nice and readable way. And on the Medium, Stefan Leon, and basically his Medium article also breaking down neural style transfer. So kind of coming into this, I had a couple questions. One was, could we actually use this technique to create a stylized photo that could be kind of like a Snapchat filter, so, you know, adds different colorations, add different effects. Another question I had is, could this work in other kind of formats, such as video, really anything? And the final thing I asked is, could we also implement this on mobile, or is it desktop specific? So before I kind of go on, I want to kind of get away with kind of get off the ground with some terminology, some tools. So the first one is going to be the content image, and essentially that's the picture that we want to get the content of. So it could be a picture of yourself, a picture of a beautiful scenery, something that we want to apply the art style to. The style photo is, it works best with a artwork that has a distinctive art style, so anything like Starry Night or any kind of art style that you can tell it has some kind of distinct look to it. The neural network that we're going to be working with and modifying is the VGG19, which was used in the original Gatsy paper. This model, I believe, was mainly used for image recognition, but we don't really care about that. We care about how it extracts features from the image. And the features are the sets of pixels that can be extracted from the image. So essentially, since these are all connected sequentially, lower feature maps extract simple features. So it could just extract like a curve, or it could extract like simple things here and there, but more higher feature maps can define more complex features. So it could identify eyes, the curvature of a face, etc. So some of the tools and libraries we're going to be using is PyTorch and TensorFlow for actually building and modifying our VGG19 network. We're going to be using Google Colab. I talked about this before in my last presentation, but Google Colab is an amazing platform that basically you can run a Python notebook on Google's cloud platform. And the really nice thing is, not only can you share this and work on this with anyone that has a Google account, but it also offers a free tier GPU that you can use. So, kind of going about it, I introduced this notion of content loss and style loss, or Leon Gatsy introduced this notion of content loss and style loss. And so, what are we kind of talking about? So, essentially, with content loss, we want to recreate our content image as best as we can while trying to keep as much. So with content loss, what we kind of want to do is recreate our content image from a random noisy image. And the reason for this is because we're also applying the style to that as well concurrently. So how we're kind of going to do this is by comparing the pixels for our noisy image or our white noise image to our content image and seeing how different they are. And then if we kind of minimize the distance between the pixels, we can iterate over that a lot of times and we can get something very close to our original content image. So kind of the steps for how that's going to work is we're going to first create a noisy image. We're going to extract content from the noisy image. Then we're going to compute the distance or the loss of distance between both the content of the noisy image and the content image. And that's to kind of estimate how different they are. And afterwards, we're going to optimize it with backpropagation. And that's, I believe in the original paper, they used the LFBJS optimizer, but from my test, Atom works just as fine too. So style loss is kind of similar to that, but instead of using a random image, we're gonna compare feature maps to itself. So how we're going to do that is by calculating the gram matrix of each layer activation, and that's usually done through higher layers. Now, the gram matrix is basically the inner dot product of a feature map, because a feature map can be any number of pixels, and we're basically going to compare. So a feature map can be any amount of pixels, and basically we're going to get an M by M gram matrix out of that. So first we're going to get the style activations from the VGG network. Then we're going to compute the gram matrix of each of those feature maps. And then finally, we're going to add the style losses together and then optimize that loss through backpropagation. So now we're almost done with this. So basically we have kind of like an optimization loop. So we'll loop through and basically calculate our losses, the content loss, style loss, and to get a better picture, there's been something called a total loss, which kind of helps with the spatial, it kind of helps with the stability of the photo more or less. So as we kind of go through it, we update the pixels on the noise image and then optimize or find a way to minimize all the losses. So when you're running this, there's a few hyperparameters you can change. You can change the content weight, the style weight, so you can have something, you can have the stylized image either look more like the content image or more like the style image. You can change how much weight comes in between each of the layers in the style. And then you can also change the number of epochs, so you can just see if you put in more training, like would you get a better result. In my test, I only see that like about maybe 300 to 500 epochs did a pretty good job, as we can kind of see on the right hand side. So the original problem with Leon Gatsy's application was even though it was like a new idea, it was super awesome, he optimizes the image after every loop. So this turned out to be very, very, very slow. And there's a lot of hyperparameter tunings to actually get a pretty considerable stable stylized image. Now, as I mentioned before, there's a couple solutions. There's proposed variational loss that kind of stabilizes the final photo, and I believe there's other losses as well that kind of speed up the network, but that can be for your own future research. So for my own application, I basically completed Leon Gatsy's application and also Zun's application of arbitrary neural style transfer. In the future though, I hope to maybe try to utilize this on the cloud to enable Johnson's method to work out really well, but that's something again for the future. And yeah, that's my presentation. Thank you for kind of sitting through this. This is a very interesting topic, and hopefully I'm excited to see what kind of work is done with it. Yeah.